Hi everyone, going to be talking about contamination in gas networks today and its effect on safety and flow assurance. So if I share my screen, we'll get straight on with it. So yes, we've got some new technology now that hopefully we can improve the efficiency of natural gas systems and detect contamination. In this case at custody transfer points, we're doing another webinar for gas processors because there's significant advantages in them monitoring the efficiency of a front-end separator before the gas comes into gas processing. But today we're going to be talking about safety and flow assurance for gas networks. So my name's Paul Stockwell, Managing Director with Process Vision. If you've got any questions, comments or feedback, it'd be great to hear from you, paul.stockwell@processvision.com. Or if you need more information on LineVu, the product we're going to be talking about, then head along to our website, processvision.com. So coping with contamination, generally once that contamination gets into a pipeline network, it's the network operator that has to cope with it in some way. And as you can see, some are pigging up to 4 times a year to remove as much contamination as they can, and others are putting extra knockout pots and extra separators in place to cope with that. And the kind of contamination that it's pulling out when it's analysed, generally there's a lot of MEG and TEG in there, some amine, and it's the liquids that are used in gas processing that are coming over with the gas at the custody transfer point. There's also lube oil on occasions, always iron sulfide, iron oxide, and some grease there as well. So it's this mixture really of a load of things really that makes this gloop up that we get to see. And well, why is this getting through custody transfer without tripping an alarm? There's a whole host of analysers there to look at the gas quality, but they're not tripping an alarm. Quite simply, they're gas analysers. You know, they're there to look at the moisture content, the H2S content, and a whole host of calorific values and other things that GCs do, but they're gas analysers. So the guidelines really are to take the sample for a gas analyser off the middle of the pipeline, middle of the pipeline diameter, specifically to avoid anything that might be crawling along the pipe walls. And there's usually a whole host of filters in between here and the gas analyzer as well. Otherwise, you know, the last thing you want to do really with the gas analyzer is fill it with liquids. So from a commercial or legal point of view, there's normally a contract in place between the gas supplier and the network. And on the same gas quality page on those contracts, there that specifies that the moisture content and the H2S content, there's usually some form of words around this kind of thing we're seeing on this contract. This is Cimarron River in the US, an interstate pipeline contract. And basically it says there shall be no liquids, there shall be no solids in the gas that's being supplied. But at the moment they can't determine if there's anything there really. And the reason for that kind of thing being in a contractual form is safety. This is an incident that happened a while back where a pipeline ruptured due to internal corrosion. And the internal corrosion was due to liquids pooling in the low point. So the gas went over this bridge here and pooled in a low point as the pipeline got buried underneath the ground again. And these things on the horizon are trees, just to give you an idea of scale. It's quite a big bang. But the other thing that can happen, as I say, the liquids or the contamination tends to pool in a low point. And it can build to a point where there's enough for a slug flow, and that slug flow then travels at a much higher speed than the original contamination coming in, and overruns any knockout pots that might be there to protect compressors and gas turbines at the end of the line. So that's when they get knocked out and gas turbines fail as well in a similar sort of way. So that's the safety. On the cost side of things, then pigging is not cheap really. Obviously you've got the cost of the pigging crew and you've got the cost of the pig itself, but on top of that, and the major cost, actually usually for the gas supplier rather than gas network, is the loss of revenue. If we take an example here at 70 bar or 1000 psi, the normal velocity in this pipeline might be 25 miles an hour, but the pigging velocity or the day of pigging is 11 miles an hour. and that's the optimum speed really for a pig. So if we take a 36-inch diameter pipe, you know, the loss of revenue on that day is $5.3 million on just one day. So that's a significant loss. And if you're doing that, you know, 2, 3, 4 times a year, that's not good. And so there's the pigging side, but there's also effect on flow metering. So the Sarbanes-Oxley bill is kicking in, and we've all got to show due diligence on fiscal measurements. And it's well known that dry gas flow meters, if they're given or supplied wet gas, then they will overread. And the figures from test loops are generally in the region of changing the uncertainty on that measurement from 0.5% to around 5%. It's quite a significant change in uncertainty, and the impact on fiscal measurements, fiscal errors, is quite large. Now, we thought that before we started this project, that during the contamination event, that's when you would see that error. But we now know with our observations that there is a permanent reduction in pipeline diameter once there's a contamination event gone through. So what we've seen is high-speed gas moving over this contamination, this mass of whatever it might be, and we've seen that draws off the lighter end liquids within the pipeline. So separation, in fact, is taking place in the pipeline, and the lighter ends sort of move much quicker than the more dense liquids, and in fact the solids. And what you're eventually left with is a solid and stationary mass on the pipeline wall. And that's a permanent reduction in diameter. It's a permanent reminder of that event. So if you apply that then to fiscal metering, bear in mind that the vast majority of this contamination is coming in with that gas, then it's got to go through that flow skid. And if you apply these kind of things with just minimal levels of contamination, the kind of things we've been seeing is sort of this sort of 2, 3, 4 millimeters of contamination at the bottom. Put that through a flow meter and it will cause an error. So is a permanent reduction of pipeline diameter. So if we apply that to an 8-inch flow meter, then you're looking at around 400K a year, and 4 millimeters again on a 6-inch flow meter. The ratios are different, so it's a more significant error, and so you're looking around about $700,000 a year. Sorry, so quite significant errors. In fact, we've generated an Excel-based flow meter calculator, so you can look at a setup that you might have, put in the number of flow meters and their diameter, and this is all, doesn't really matter about the technique of the flow meter, whether it's an orifice plate or ultrasonic or Coriolis. This is physics. This is just a general decrease in the pipeline diameter compared to what you've told the flow computer that you've got, so this, then you can calculate what the effect of that contamination is, just with a few millimeters or whatever. We'll do a separate webinar on this and go through it in more detail. But what we have is LineVu, and this is what we've developed to cope with this kind of thing and report this contamination taking place, so that operators can take action in exactly the same way as they would do is if the gas went out of spec in terms of moisture or H2S, they would take action. Then, you know, if it's entrained contamination coming across, then they can take the same sort of action. And the camera sits, and the illumination system sits on top of the pipeline, looking through an isolation valve generally, and looks to the pipeline below, and we can see any activity on the pipeline floor here. So as I was saying earlier, gas producers or gas processors can also have great benefit from monitoring the efficiency of the front end separator on gas processes as well, but that's a separate issue. So this is the user interface, and as you can see, this is what you'd see if you stood on top of the pipeline looking down, and this is sort of a mass of stuff here. These are housekeeping data. We can add process data to this if we've got access to it as well. So that's about it. Give us a shout, paul.stockwell@processvision.com. I'll speak to you soon.